Hello, we will continue with the absolute motion and relative motion exercises. A swimmer departed from point A and moves at a constant speed v equal 4 meters per second with respect to the water of a river of width d equal 50 meters and whose waters are animated by a current of constant speed u equal 2 meters per second. Find the time needed to get to point B directly opposite to point A. So we have a swimmer on the border of a river. He is at point A. He wants to go to point B such that AB is equal to the width of the river equal 50 meters. In the river, we have the speed of or the velocity of water equal to u. U is a constant. We need to find the time needed to get to point B directly opposite to point A. Okay, and they gave us V. What is V? So V is equal to 4 meters per second with respect to the water of a river. So V equal 4 meters per second is the speed of the swimmer relative to water which is moving. Okay, so they gave us two speeds. First, they gave us the speed of water with respect to an observer at rest. So U here is an absolute speed, whereas V is the velocity of the swimmer with respect to water which is moving. So here V is a relative speed. Okay, so we need to find the time needed to get to point B. In the question, this time is measured by an observer at rest. Okay, so if we have, for example, here an observer at rest, he will see the swimmer. So here we have the observer O. He will see the swimmer going from A to B, traveling a distance d, and he will see the absolute speed. He will see the absolute speed. Let's say this is VA. And he will measure the time needed to go from A to B. So the observer will measure an absolute speed, and he will also measure the time t. So the time t is related to the absolute speed. So if we want to draw a figure, so the swimmer is going from A to B with an absolute VA. So VA is the absolute speed measured by the observer at rest. U is the speed of water. Let's write the rule. We know that VA is equal to VB plus VA with respect to B. So this is the formula. It's the same as V absolute equal V driving plus V relative. So the absolute velocity is equal to the driving velocity plus the relative velocity. So here we are measuring the absolute velocity of the swimmer. So VA is for the swimmer. Vd, the driving velocity, by definition, it's the velocity of the moving frame. The moving frame here is water, so Vd is for V water, plus V relative. V relative is equal to V of the swimmer with respect to water. So V of the swimmer with respect to water. In the given, they said that V swimmer with respect to water is V, and V of water is represented by U. So finally, we can write V swimmer absolute. So the absolute velocity of the swimmer is equal to U plus V, and they want us to find the time needed to get from A to B. So they want us to find V absolute, so Vs. How can we find Vs? So we need to find Va, which is the same as Vs in this equation. So Va is equal to U plus V. How do we draw V? In fact, V is the velocity of the swimmer with respect to water. So if water pushes the swimmer to the left and he will finally get to point B, then V should be directed to the right and oblique in this way, such that U plus V equal VA, which is Vs. So here V plus U is equal to VA. So VA is equal to U plus V. How do we find VA? In fact, this triangle is a right triangle, so we can write that V squared is equal to VA squared plus U squared. Then we can deduce that VA squared is equal to V squared minus U squared. So V squared is equal to U squared plus VA squared. This means that VA is radical of V squared minus U squared, which is equal to radical of V. V is equal to 4. So we replace V with 4 and U with 2. And we will finally obtain V absolute, the absolute velocity or the absolute speed of the swimmer. It's radical of 12 meters per second. This is a constant speed. So this speed is the absolute speed that is measured by the observer at rest. This observer at rest will measure time t. What is the time required for the swimmer to go from A to B? It's equal to d over V. Why? Because here V is a constant. If V wasn't a constant, then we would not be able to write t equal d over V. Okay, so t is equal to d, which is equal to 50, over v, which is radical of 12. Finally, we obtain t equal 14.4 seconds. So the idea of this exercise is to know what is the absolute speed, what is the relative speed, and what is the driving speed. So the absolute speed is the speed measured by an observer at rest. Our observer O measures the absolute speed. He will see the swimmer going from A to B in a straight line. Okay, but for the swimmer will go first to the right and oblique, such that V plus U is equal to VA. Here, the driving speed is the speed of the moving frame, which is the speed of water. It's equal to U.